Welcome to this lab on verification of Ohm's law. So in this this is a circuit. So we have a battery, we have a rheostat, a meter, resistance and voltmeter. So we're going to study the variation of current and voltage here. And this circuit here, which is a battery and the rheostat, is what we have as a current regulator. So let us see this setup. You have this battery. So this battery is you can set up different voltages and you can switch it on. This battery is connected to a rheostat. So using this battery and rheostat, I can change the current. So I can increase or decrease the current. So this acts as your current regulator. Then we have the ammeter, and the ammeter is connected to this resistance box. That resistance box is connected to the voltmeter in parallel. So you can see that in series is an ammeter and in parallel is the voltmeter, right? And these readings will change as I pass the current. So let's take the readings for different values of current and voltage. So first let me adjust the voltage such that it shows about 3 volts. So let's see if it's about 3 volts. So I'm changing the rheostat current so that the voltage changes. That's quite sensitive, yeah. Right, so that's it. You have 3 volts. And you can see the ammeter reading. The ammeter reading is about 1.35. So yeah, that's 1.35. So let's take this down. So the first reading is the voltage. The given voltage would be 3 volts, and your current would be 1.35 amperes. So let's take the next reading. Let's bring down the current from 1.35 to let's say 1.1. So that's about 1 amperes. So I'm changing the rheostat to get more or less current. Yep, that's close to 1 ampere. And the voltage, you can see the voltage. The voltage is about 2.25, one least count after 2.25, that's 2.3. So 2.3, and just let's take this once more. So that's 1, yeah, that's 1 and 2.25. Okay, so let's take this voltage as 2.25 volts with 1 ampere. So let's take 3 more readings like this. So here are the readings for this experiment. We have taken 3 more values, and you see all the resistance are all hovering around 2.2, and the average resistance is 2.22 ohms. And if you see our resistance box, so the resistance box is set under 2 ohms. So we have taken out the 2 ohm plug. So essentially that means that the resistance set was 2 ohms. So now next we need to calculate the slope of this graph. So before we do the slope, we plot all the points between V in the y-axis and I in the x-axis, and we have plotted all these points, and we got to draw the best fit line. And the best fit line is something that passes through all the points. It necessarily need not pass through all the points, but the variance should be of the points across both sides of the line should be same. So here we are pretty close to the straight line. So then we need to take any 2 arbitrary points in this line which are not plotted, and we need to calculate our slope. So let's now calculate the slope for this. So once you have identified two non-plotted points, you can find out what those points are. So this is your x-axis is your I, and this is your V, and this is your I, and this is your V. And you can find your delta V, which is the difference between these two V's, or this height, and delta I as the difference between this and this, so that's this length. Now once you found your delta V and delta I, you can plug it into your equation of slope, which is delta V by delta I, and calculate your slope. So this is your resistance using the graphical method, and this one, the average that we have got experimentally. So this is using the average of all the readings. So I hope you enjoyed this video and it was useful for you. See you in the next one.